Hi everyone, welcome to this video on Introduction to Scientific Notation. It's Mr. H with you here. We're going to consider two numbers, one that's very big and one that's very small. The first one, the mass of the Earth, is 5, a 972, and then 21 zeros after that. And the mass of an electron, which is very, very small, is 0.30 zeros followed by a 9, 1, and a 1. So you might wonder, well, if we're making calculations with numbers that are these big, this size, how in the world could we actually type these in a calculator? Well, we don't type them in a calculator like that. We use something called scientific notation. And so just to understand scientific notation, we're going to go over the powers of 10 here together. If you have anything to the power of 0, hopefully you remember that that means it's equal to 1. 10 to the power of 1 is just 10. 10 to the power of 2 is 10 times itself, so 10 times 10 is 100. 10 to the power of 3 is 10 times 10 times 10, so it's 10 times 10 is 100 times 10 is 1,000. And then every power of 10 bigger you get adds a 0. So if we have 10 to the 0, it's no zeros. If we have 10 to the 1, it's 1 0. 10 to the 2 is 2 zeros, etc. We can also write negative powers. So again, if I start just so we can see the pattern with 10 to the power of 0, that's 1. But if I write 10 to the power of negative 1, what that means in terms of exponents is that it's 1 over 10 to the power of 1. So we write it as a positive exponent but down now in the denominator. Well, that's just equal to 1 over 10. Let's see what that looks like in terms of 10 to the negative 2. That means 1 over 10 to the power of positive 2 if it's now in the denominator. Well, 10 times 10 is in the denominator, so it's 1 over 100. And then we can continue that going. This is 1 over 10 to the 3, which is 1 over 1,000. And this is 1 over 10 to the 4, which is 1 over 10,000. Now fractions don't get really nice here, so we're actually going to change these. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. 1 divided by 1,000 is 0.001. And 1 divided by 10,000 is 0.0001. Now, this might help you realize why we use these numbers like hundredth and thousandth and everything. This is a tenth, and it's a tenth because it's 1 divided by 10. This is a hundredth because it's 1 divided by 100. This is a thousandth because it is 1 divided by 1,000, etc. Now, you'll notice the pattern, I hope, that on the left side, the powers are growing by 10 every time, and that would be positive exponents. So if we have a really big number like the mass of the Earth here, we would use a positive exponent on the 10. If we have a really small number like the mass of an electron, we would use a negative exponent. So let's look at how we actually calculate these. Let's just consider one smaller number before we look at these very large and very small numbers first. 5,875. Here's how we write this in scientific notation. If we were to think this was 5.875, we're always going to write the decimal right after the first number. What would you need to multiply that by to get it to equal 5,875? Well, you would have to multiply that by 1,000. If you multiply it by 1,000, the decimal place would come over 3 places back to the end. Well, the same way of writing 1,000 is writing, as we have above, 10 to the power of 3. And so in scientific notation, this number 5,875 is equal to this number 5.875 times 10 to the power of 3. Likewise, if we take another small number, let's take this number like 0.0054. And if I want to figure out how I would multiply that, I'm going to start by writing it with the first digit that's non-zero, followed by a decimal place, so 5.4. What are we going to have to multiply 5.4 by to get 0.0054? Well, we're going to have to multiply that by 10 to the power of negative 3 in this case, 0.001. Right? If you think about it, if you multiply those two together, the decimal place is going to go over 1, 2, 3 places, 1, 2, 3, and you're going to be left with 0.0054. Well, that's the same thing as saying 5.4 times 10 to the negative 3, as I already noted. And that is equal to this. What's the trick? The trick is this. The trick is to go ahead and look at a number like the mass of the Earth and count the number of, if I was to put the decimal place after the first non-zero digit, how many numbers are still left? Well, here we've got 3, 6, 9, 12, 15, 18, 20, 24. And so we write that as 5.972 times 10 to the 24 kilograms, because I've moved the decimal place from that point that it was originally right there at the very end of the number, 24 places all the way to the left. 24 places to get over here. So we're multiplying 5.972 times 10 to the 24, and that is how it is written in scientific notation. In terms of the mass of an electron, we're now going the other direction, and because it's a smaller number that's smaller than 1, it's going to be a negative exponent. And so we're going to say, well, I'm trying to get the decimal to go from here, where it is right there, all the way over to here. Well, what do I have to do? Well, I have to move it over 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 31. And so we write this as 9.11 times 10 to the negative 31 kilograms. If you look those numbers up, those are the numbers that you'll find for the mass of the Earth and the mass of an electron. And you'll always be given those, not in terms of these big number or the really small number that I've shown you there on the left, but you'll always be given it in scientific notation when you look that up online. One final example if you're having trouble with this. When light moves through an empty space or even through air, the speed of light is going to be 300 million meters per second. That's very fast. 300 million meters per second. That's a big number to write out over and over again. So what we're going to do is we're going to identify there again that the decimal would be right there, because that would be the end of the number. And then we're going to go over 3, 6, 8, and we're going to put the decimal right there. So we're going to write this as 3. You could write it as 3.00. You could put it as many zeros as you wanted, but we're going to write it as 3 times 10 to the 8 meters per second. And this is the foundation of what we're going to do with refraction.